Hi, and welcome to Lockdown Learning with Guardians of the Deep. I'm Sally, and today we are going to be exploring the beautifully diverse world of coral reefs. By the end of this presentation, you'll be able to answer all of these questions. This quiz, along with a number of others, can be found on the Lockdown Learning page of my website, scientistinlimbo.com. You can pause the video now if you'd like to make a note of these questions, or just if you'd like to take a screenshot or photo so that you can answer them as we move through the presentation. Coral reefs are beautiful, brightly colored ocean ecosystems that are teeming with life. Characterized by the reef-building corals, these colonies of coral polyps belong to the animal phylum Cnidaria, along with sea anemones and jellies. A phylum is just a high-level rank for a group of organisms that share a set of characteristics, distinguishing them from other organisms in another phylum. The distinguishing characteristic for Cnidaria is that these animals have cnidocytes, which are specialized cells used mainly for capturing prey. The name Cnidaria is derived from Greek, meaning sea nettle. Coral reefs are colonies of tiny polyps living in secreted calcium carbonate skeletons. The diagram on the right shows a close-up of one of these coral polyps. The zooxanthellae within the tissues of the tentacles are microalgae, dinoflagellates, that provide the polyps with most of their energy. The zooxanthellae converts energy from sunlight into nutrients for the coral, and the coral in turn provides these dinoflagellates with protection and carbon dioxide. This is an example of a mutualistic symbiotic relationship, an interaction between two species where they both benefit. I'll discuss symbiotic relationships a little bit later in the presentation. While zooxanthellae provide the coral with most of their energy, the rest of their diet is made up of zooplankton and particles of organic matter. At night, the polyps stretch their long stinging tentacles out of their skeletons and into the water column to feed on the plankton floating past. High temperatures cause the corals to stress, which leads to bleaching. So if the sea temperature is too warm, corals will expel the zooxanthellae living in their tissues. And because the zooxanthellae are their main source of energy and color, this expulsion causes the coral to turn completely white. A bleaching event doesn't immediately kill the coral. It can survive. It is just under higher levels of stress. So if the temperatures remain too high, they will eventually die. In this state, they are also more susceptible to disease. When healthy coral reef ecosystems have one of the highest biodiversity levels on Earth. Occupying less than 1% of the ocean floor, coral reefs are home to more than 25% of marine life. These reef ecosystems come in four main forms. Fringing reefs are the most common type, growing near the coastline and separated from the shore by narrow, shallow lagoons. Barrier reefs run parallel to the coast, but are separated from it by deeper, wider lagoons. Atolls, the third reef type, usually form when islands surrounded by fringing reefs sink into the sea. These islands are often the tops of underwater volcanoes, usually located in the middle of the sea. The reef continues to grow, forming a ring around a protected lagoon. Platform reefs are isolated reefs that usually occur on the continental shelf. At 2,600 kilometers long, the Great Barrier Reef is the largest living structure on Earth and can be seen from space. Coral reefs have been around for 500 million years, so even though the Great Barrier Reef is 500,000 years old, it is still relatively young, and with the modern version only being approximately 8,000 years old. Even though it has been around for so long, due to a few large-scale bleaching events in recent years, over half of this reef is dead. We'll chat a bit later in the presentation about how our choices, the choices that we make every day, can help to preserve these fragile environments. Now I'd like you to have a look at this background. I took this photo off Reunion Island last year. In terms of environmental conditions, what requirements stand out to you? What conditions, abiotic factors, do you think coral reefs need to grow? From this photograph, I can see that this reef is in shallow, sunlit, clear, and relatively clean water. So coral reefs occur in the photic zone, that's the sunlight zone, down to a depth of about 50 meters. This is so the zooxanthellae are able to photosynthesize. Water quality is another condition evident in this photo. The quality of the water determines how much sunlight is able to shine through. This means that the water in which coral grows has to be clear. That means no sediment, no nutrient upwelling, and no phytoplankton blooms darkening the water column. The water also needs to be clean. Pollution both darken the water column and damage the coral, as well as changing the chemistry of the seawater. Pollution can lead to sedimentation, smothering the coral, and an increase in the nutrient load, leading to phytoplankton blooms, further damaging the coral. Using a chemical type of sunscreen while in the water contributes to this pollution, as the chemical ingredients are toxic to coral and other marine life and cause permanent damage. The other three environmental conditions that are not clear in this photo are salinity, pH, and temperature. So coral reefs require salt water to grow, and the salinity, or the saltiness of this water, needs to be between 32 and 40 ppt. ppt stands for parts per thousand, and it's one of the units scientists use to describe the saltiness of the water. So for every 1,000 grams of water, that's approximately a liter, there is 32 to 40 grams of salt, which is approximately 2 to 2.5 tablespoons of salt. Even though coral reefs occur within a salinity range, they require the salinity to remain relatively stable. Therefore, they don't tend to be found near estuaries, where rivers are continually releasing fresh water into the system, changing the salinity, diluting or making the water less salty in the area. pH is important because as oceans become more acidic, it affects the integrity of the coral skeleton, as it also does to so many shelled animals. Water that is more acidic will break down and dissolve calcium carbonate shells and corals. What also isn't clear in this photograph is the seawater temperature. Coral reefs occur in a band along the equator in water with a temperature of between 23 and 29 degrees Celsius. It was about 28 degrees Celsius when I took this photograph, and it really did feel like a bath. So symbiotic relationships are relationships or interactions between two species, and they are classed by looking at whether or not there is an impact on one or both of these species, and if this impact is positive or negative, good or bad. We'll start with mutualism. This type of relationship is beneficial to both species, meaning that both species are getting something positive out of the relationship. We've already learned about the coral polyps and the zooxanthellae. The polyps getting their energy from the zooxanthellae, while the zooxanthellae get the safe space to live and carbon dioxide from the polyps. A similar relationship occurs between nudibranchs and zooxanthellae. Nudibranchs are beautiful, brightly colored sea slugs that also get energy from zooxanthellae, while these dinoflagellates are able to get safely sheltered within the tissues of the nudibranch. Nudibranchs are really cool little creatures that have appendages called rhinophores on their heads. These rhinophores look like upright ears and are chemosensory organs used to taste or smell. Next week, we're going to be looking at the floating blue community, and one of the organisms in that community is the sea swallow. It's one of my favorite nudibranchs, so we'll learn more about that next week. Another mutualistic example is that of the sea anemone and the clownfish. Think of Nemo and his tentacled home. The anemone provides protection for the clownfish and their eggs, while the clownfish protects the anemones from predators like the butterfly fish, as well as removing parasites from the anemone's tentacles. The external mucus layer of the clownfish protects them against being inadvertently stung by the sea anemone. This mucus layer is about 3 to 4 times thicker than that of related fishes not living in anemones. Commensalism benefits one species while the other species is not affected. So an example of this would be sponges and coral. Sponges use the coral skeleton as a place to anchor, and the coral is not affected by this. Further to that, various tiny organisms live within the sponges, and they get shelter, but the sponges aren't affected by their presence. Parasitism occurs between a parasite and a host. The parasite will benefit from the relationship while negatively impacting the host. An example of this would be the Christmas tree worm burrowing into the coral. The worm gains shelter but breaks the coral in the process. Competition is an interaction where both species are negatively impacted through the struggle of sharing limited resources. The resource could be space, food, light, depending on what the two species are. Predation is the interaction between predator and prey. The predator gains a meal when it catches its prey. The crown of thorns sea star is a predator known to devastate entire reef colonies. Now, I'd like you to think about what you've just learned about coral reefs and the environmental conditions they require to survive and grow. Sunlight, shallow, warm water, and so on. Taking these conditions into account, do you think coral can grow in the deep sea, where it is dark, deep, and cold? The answer is yes. There are coral gardens flourishing in the dark depths of the ocean. Recent advances in ocean exploration have revealed spectacular deep-sea coral gardens that are just slightly different to their tropical counterparts. Occurring below 200 meters, down to the bathypelagic or midnight zone, deep-sea corals grow in the darkness of all the ocean basins, where the seawater temperatures don't rise above 4 degrees Celsius. As there is no sunlight at these depths, zooxanthellae do not live within the coral's tissues, which means that deep-sea coral is slower growing because it has to depend wholly on sourcing its own food. The coral polyps are bigger, increasing the amount of zooplankton and other organic matter that can be extracted from the water column. At these depths, rock-like coral reefs are not formed. The corals grow in groves of tree and feather-like structures. A black coral species is one of the oldest animals on Earth, aged at 4,265 years old. As they grow, coral incorporate ocean elements into their skeletons, making them archives of ocean conditions. Both the tropical and deep-sea coral environments are facing an array of threats. Climate change is having a devastating effect on corals, with rising sea temperatures leading to many widespread bleaching events, the rising sea levels making the corals sit deeper, and an increase in the frequency and intensity of storms resulting in the large-scale destruction of habitats. The ocean is having to absorb high levels of atmospheric carbon dioxide, which results in a decrease in the pH, meaning the water is more acidic, and the breaking down of the calcium carbonate skeleton of the coral. The depletion of the ozone means that the intensity of the ultraviolet radiation reaching the Earth's surface increases, and although corals have a natural sunscreen, at this increased level, this radiation can damage the shallower corals. The localized threats are just as damaging. The impacts of overfishing are not just limited to coral reef ecosystems. The knock-on effects ripple throughout the marine environment, disrupting nature's delicate balance. Overharvesting of herbivorous reef fish, such as parrot or surgeonfish, results in the accelerated growth of algae, which will eventually smother the reef. The reef will no longer be a healthy ecosystem, and its ability to properly function will be compromised. Pollution will affect the quality of the surrounding water and can be in the form of discharged wastewater, agricultural runoff, and such from land, which overburdens the system with nutrients and toxins. Pollution can also be in the form of marine debris, floating trash that hooks on reefs, blocking out the sun and also breaking it. Habitat destruction has far-reaching and long-lasting consequences, especially in a reef environment because coral grows so slowly. Destructive activities include the removal of large quantities of coral for construction purposes, the building of piers and other structures on top of the coral, destroying it and the possibility of recovery, using or buying coral as gifts, blast and cyanide fishing, bottom trawling, dropping boat anchors directly onto the reef, and irresponsible tourism. There are, however, a number of organizations and initiatives carrying out research and conservation efforts to better manage and protect these delicate ecosystems. WWF works on the global policy issues facing reefs in an effort to reduce the threats. And they do this by working with government, local communities, and other global initiatives. One of these organizations being the Coral Reef Rescue Initiative, which is identifying the most climate change resilient reefs and protecting them from the impacts of overfishing, pollution, and unsustainable development. The National Oceanic and Atmospheric Administration use a multidisciplinary approach to understanding and conserving coral reef ecosystems through their Coral Reef Conservation Program. Here in South Africa, we have the unique situation in that 100% of our coral reefs are protected and monitored in two marine reserves, Maputaland and St. Lucia, along the northern KwaZulu-Natal coast. There are also choices that we can make every day that can be used to help preserve coral reef ecosystems. When eating fish, use the SASSI list of species to make a low-impact choice. Choose to eat green by supporting sustainable fisheries. Don't litter. Clean up your neighborhood and participate in local beach and river cleanups. If you dive on a reef system, don't touch it. Use mineral-based, eco-friendly sunscreen. Don't remove coral from the reef or buy coral products. So how many of these questions can you now answer? If you would like to test your knowledge on any other ocean elements, you can find a bunch of quizzes on the lockdown learning page of my website, scientistinlimbo.com. You can play the memory game, test your knowledge, and explore the coral reef ecosystem with Coral Reef Adventure. And you can check out some cool marine science lessons with Reef Relief. These links are available under Lesson 4 on the Lockdown Learning page of my website. That learning page also has a bunch of ocean-themed activities, crafts, and learning resources. If you'd like to participate in or contribute to citizen science projects, check out Zooniverse. That link is also under Lesson 4. Before I explain the activities, I'd like to know if there is anything specifically relating to the ocean that you would like to learn about. You can email me on guardiansofthedeep@yahoo.com with your requests. So activity 1, we have discussed both tropical and deep sea coral and examined the differences in the environmental conditions of both systems. Draw a diagram of each ecosystem and see how many differences and similarities you can spot between the two. What are the fish going to look like? In these dark depths, is the coral and subsequently the animals going to be brightly colored? Activity 2 involves some imagination. Choose your favorite reef species, dress up like them as best you can, and then act out how it would spend its day. Remember that if you choose to be a crab, you'll have to spend the whole day walking sideways. But if you're an anemone, you can sit in one place and wait for the food to come to you. Just don't forget to wave your arms enthusiastically in the air to catch it. Next week, we'll be learning about the very awesome floating blue community. Thank you so much for watching. See you next week. Bye.